Okay, here mitosis, which is also called as mitotic cell division, and equational cell division. This mitosis takes place in vegetative or somatic cells. Somatic cells of the body. Vegetative or somatic cells of the body. These vegetative and somatic cells are responsible for these cells are responsible for growth of organism, repair and replacement. Growth, repair and replace. How it will? Okay. What I will explain. First, we'll discuss about mechanism of this cell division. Mitosis. Suppose if you take a vegetative cell or somatic cell of the body, always vegetative cells are 2n in condition. 2n means diploid state. 2n means two pairs of chromosomes. We can find here two pairs of chromosomes. 2n condition. If only one pair is present, that is called haploid. Always vegetative cells of any organism's body are in diploid state. They should be in diploid state. Now, if the cell undergoes mitosis, already I told you, mitosis is also called as equational division. Equational division means the cell divides equally into two data cells. One cell divides equally into two data cells. That means if this cell directly participates in mitosis, okay, it gives two data cells. When it divides equally, one pair enters into one data cell, one pair enters into another data cell. Means in these data cells, haploid condition is there. Only one pair means one and haploid. But first itself I told you vegetative cells should be in diploid state. Okay, but here there is a chance of getting haploid condition. That is why to avoid haploid condition, before entering into mitotic cell division, the existing DNA material doubles in amount. Yesterday I told you during S phase, synthetic phase, DNA replication takes place. Means 2n becomes 4n. Okay, no, we should not say like that. 2n becomes 2n only, but instead of 2 pairs, 4 pairs are present. Okay, suppose x is one pair, y is one pair. X is one pair. Both of x is having different characters, y is having different characters. With different set of characters, it is called one haploid, one n, one pair. This is 1n, 2n. Okay, now x duplicates x1, y duplicates y1. X and x1 are same duplicates. Y and y1 are same duplicates. Though here 4 pairs of chromosomes are present, only 2 characters are present, that is x and y. That is why we cannot say it as 4n. If you want to say it as 4n, x, x1, y, y1, every pair should have different characters. But here, same. That is why no 4 pairs are there, it is considered to be 2n. That means here, before entering into mitosis, the chromosomal number doubles in the cell during the S phase. Means a vegetative cell enters into mitosis with double amount of chromosomal material. Okay. Now, this mitosis has majorly 2 stages. One is karyokinesis and cytokinesis. Karyokinesis and karyon means nucleus. Kinesis means splitting or division. Cyto means cell. Same kinesis means division. Okay. During mitosis process, first karyokinesis means first cell directly will not divide into two data cells. First, inside the cell, whatever the nuclear material, that is chromosomal material is present, that nuclear material divides. Okay, inside the cell, that process is called karyokinesis. After the completion of nuclear material division, next the cell divides. Okay. Now this karyokinesis involves majorly 4 stages. One is prophase. Second one, anaphase. Third one, telophase. And fourth one, excuse me, prophase, metaphase, anaphase, and telophase. Okay, karyokinesis, nuclear material division involves majorly 4 stages: prophase, metaphase, anaphase, and telophase. Now, what happens during this prophase or metaphase? Now, usually when a cell is in resting stage means interphase. Interphase means G1, S, G2, gap 1, synthetic phase, and gap 2 phase. 3 of them together called as interphase. During resting stage means when cell is not undergoing cell division, the nuclear material is, suppose this is nucleus, the nuclear material is in irregular network form. This is called chromatin. Irregular form of nuclear material, genetic material is called as chromatin. Now this cell, when it enters into prophase. Okay, the first thing is chromatin. 1 minute, I think. Complex efficient. Yeah. Prophase. During prophase, what happens? If you observe the cell during prophase, it is like this. What happens here is number 1, chromatin condenses and form chromosomes. Irregular network like material chromatin condenses and form rod like chromosomes. Number 1. Nuclear envelope nucleolus, and all other cell organelles disappear. Disappear means they disintegrate and dissolve in the cytoplasm. Next, centrioles move to opposite poles and form spindle fibrous. Centriole. This is one centriole. This is another centriole. Move to opposite poles of cells, form spindle fibers. Okay. These spindle fibers attach to the chromosomes. These spindle fiber attach to the chromosomes. Once again, during prophase, the chromatin condenses and forms chromosomes, rod-like chromosomes. Nuclear envelope, nucleolus, all the cell organelles disappear. And centrioles, except centrioles move to opposite poles and form spindle apparatus. The spindle apparatus are spindle fibers attached to the chromosomes from both sides or both poles. Okay. Next, metaphase, simple. All the chromosomes come to one plane and forms equatorial plane. Here the chromosomes are now and there here in the prophase. Such type of chromosome comes to a single plane and forms a structure called equatorial plane. We can observe, if you want to observe the chromosomes properly, we can best observe chromosomes under microscope at this particular stage, that is metaphase. Only one thing happens during metaphase, that is all the chromosomes are formed onto a single plane and forms a structure called equatorial plane. Next, anaphase. Anaphase. Here, spindle apparatus pull the chromosomes towards the opposite poles. As a result, chromosomes split longitudinally or lengthwise and move to opposite poles. Chromosome structure is like this. This is centrosome. Okay. Spindle fiber pull the chromosomes. As a result, chromosomes split longitudinally and move spindle fibers pull chromosomes. As a result, chromosomes split lengthwise and move to opposite poles. Move to opposite poles. Next, telophase. Telophase is reverse to the prophase, equal to say reverse to the prophase. Here, chromosomes spindle apparatus or spindle fibers disappear. Okay. Chromosomes decondense on both poles. Okay. To form chromatin. To form chromatin. Here, on both poles, chromosomes decondense and form chromatin. Nuclear envelope on both sides, nucleolus, and all other cell organelles reappear. That is why I told it is reversal to the prophase. During prophase, nuclear envelope, nucleolus, and all other cell organelles disappear. Here, nuclear envelope, nucleolus, and all other cell organelles reappear. This is telophase. With this, karyokinesis completed. Nuclear material division completed. Now, cytokinesis. 1 minute. Once again, I am explaining. In karyokinesis, there are 4 stages. One is prophase, metaphase, anaphase, and telophase. During prophase, the chromatin material condenses and forms rod-like structures called chromosomes. Nucleolus, nuclear envelope, all other cell organelles disappear. Centrioles, except centrioles move to opposite poles and form spindle apparatus or spindle fibers. Those spindle fibers get attached to the chromosomes. During metaphase, second phase, all the chromosomes comes onto a single plane and forms a structure called equatorial plate. We can observe the chromosomes best in this particular structure. Next, anaphase. The spindle fibers pull the chromosomes towards opposite poles. As a result of pulling, the chromosomes split lengthwise and move to opposite poles. Telophase, both phase, the last phase in karyokinesis. The chromosomes which are moved to the opposite, split chromosomes which are moved to opposite poles, they decondense. Here, condensation. They decondense and form chromatin. Around that chromatin on both sides, nuclear envelope develops, nucleolus develops, all other cell organelles reappear. Okay, here chromosome and material separated here. Next, cytokinesis. Second stage in mitosis. Cyto means cell, kinesis means division. Now centrifugal. Suppose this is the cell with nuclear material or with 2 nuclei on opposite poles. Slowly at the center of the cell, small constriction from both the sides starts. The constriction exceeds, and finally one cell divides into 2 daughter cells. One cell divides into 2 daughter cells. Each daughter cell is in diploid state only. How it is possible to maintain diploidity means, because I told you before entering into the cell division, the chromosomal material doubles. That is why equal amount of chromosomes entered here. Okay, 2n, 2n. Okay, with the help of mitosis in vegetative cells, it is possible to maintain always diploid condition. Like this, one parent cell gives rise to 2 daughter cells through mitosis. These 2 daughter cells pass through gap 1 phase, synthetic phase, gap 2 phase, and again participates in mitosis and give rise to new daughter cells. This process will continue. Okay. Next, what is the use of mitosis? Mitosis helps in importance of mitosis otherwise. Mitosis helps in growth of organism by adding cells. Okay, by adding cells, it helps in growth. Next, helps in repairing wounds. When we get an injury, a small tissue, okay, we may loss. Okay, automatically after some time the wound heals. How wound healing happens means with the help of mitosis. Mitosis, the cells in the edge of that wound undergo mitosis and add up new cells and helps in healing of the wound. Next, helps in replacing worn out cells with new one. Worn out cells means after doing work after several days, the cells may get inactivated, means they cannot work effectively. The cells which cannot work effectively, those cells are called as worn out cells. That cells should be removed and the effective cells should be added to carry out the physiological activities properly. When cells are worn out, those cells are replaced by new cells with the help of mitosis. Like this, mitosis helps in growth of organism, helps in repairing wounds, and helps in replacing worn out cells with new cells. Like this, mitosis plays an important role in living organisms' life. Without mitosis, there is no growth of the organism, no replacement of the cells, no repairing of wounds, and even in unicellular organisms like amoeba, they can multiply their number by this mitosis only, binary fission. One cell divides into two. How it divides is through this process. Okay, this is about mitosis. Please, I will send the pics. Follow these pics. Read from your textbook. This is very, very important because tomorrow I am going to explain about meiosis, reductional division. Meiosis, if you are able to learn before tomorrow's class this, if you get clear idea, meiosis is very, very simple task. Without understanding this, it will be the tough task. If you understand this, if you read this, get an idea, automatically you can understand tomorrow's meiosis topic very easily. I will send the pics to you. Okay, please go through them.